Hello and welcome to this first lecture in this new section in real life case reviews. So in this lecture what we're going to do is to take you through this problem analysis that the NASA engineers did for the trouble aboard Apollo 13, right? You remember Apollo 13 that was sent towards moon and had to come back? Right, so that's what we're going to talk about. So it was the Apollo 13 was on its way to moon and about 200,000 miles from Earth, 55 hours roughly, all was well. And then suddenly the Houston receives a message saying that we've got a main bus underwater. Now that was a technical term, but basically means that electric voltage on the second of the two power generating systems had fallen off and a warning light had appeared. A moment later, the power came up again. So the voltage is looking good, it was reported. But again, the problem did not go away and says 3 minutes later, the dimensional problem became clearer. And it was reported that yes, we've got a main bus A underworld 2. It is reading 25 one half. Main bus is reading zip right now, zero, that means. So there was a problem. Apollo 13 carrying three people towards moon at incredible speed was losing power rapidly and could shortly become a dead body. The disaster had occurred in space and no one was sure what has happened. So that was the situation. And what you need to understand and see is how did they find the root cause, which was not very quickly they could do that, right? So what would you do in this situation? Any thoughts? And let's look at what did the NASA engineers do and compare and contrast to what the NASA engineers did versus what you thought you could do. So they put the problem analysis question into work immediately and they started building specifications of the deviations. The deviation they assumed was loss of power, right? And then the data was analyzed. At the same time, they started making a lot of contingency action to reduce the loss of electrical power on board Apollo 13. So that's what NASA engineers did. Now, was it the right thing to do? Question for you. What should have they done in terms of the problem analysis? Right? Any thoughts before I go and tell you my cards, open my cards? Right. So the contingency actions were right because it was a very high risk situation. Life of three people were involved and of course millions of dollars. So, but the specifying deviation was not right. Why? Because they had still not filled, as you will see, they should have asked questions to better state the problem. They stated the problem as saying we are losing power, right? Now that doesn't seem to be the right problem to solve. And why? Because they did not drill down. While it was focused on one deviation of a time and it was stated implicitly that the power should not have been lost, but question was did they drill down to the level where the cause was unknown? And if they had done that, waited for some time to do that, they would have discovered the real problem. Only 30 minutes after the first report, they got the report saying our O2 cryo number 2 tank is reading zero, which basically said oxygen tank, that is the number 2 oxygen tank has no power. It is, and it looks to me, looking through the hash, that we are venting something out into space. It's some kind of a gas. So what began as an electrical problem, loss of voltage, became now suddenly loss of oxygen in the second of the two tanks. And with a more gradual loss of oxygen from the was. Since oxygen was used in generation of electricity as well as directly in life support system, situation was more serious, right? And we now knew the cause of the loss of electricity was generation of electricity was the loss of oxygen. So the problem was really the loss of oxygen from the tank number 2 and continued loss from tank number 1. So obviously they couldn't do the problem analysis in space as much as they would have liked to do. But what they found ultimately was that rupture of number 2 cryogenic oxygen tank would explain the sudden loss of voltage and subsequent loss of pressure. So further actions were taken to conserve both oxygen and electricity, and number of is and could be, is and is not were asked to further get into data, and a series of systems checks were undertaken to verify the cause. And they figured out that the number 2 tank had burst and vented all its oxygen, plus a large portion of gas from number 1 tank through a damaged valve was being let out into space. Now, thanks to the contingent actions of conserving electricity as well as oxygen, all the three people returned safely to the earth, but only by the narrowest of the margins. And still we haven't found the root cause of the problem, right? So the problem was now stated as rupture of number 2 cryogenic oxygen tank, and we still haven't found the root cause. What caused this? So let's look at how do we find that. So the problem was described now as when the team came back to on ground to earth, it was described as is as number 2 tank and is not at number 1. So the problem statement, what was the deviation? It was a rupture, not a leakage. And where it was the deviation, it was in number 2 tank. It was not in number 1. That's very interesting thing, right? And that's the beauty of this process. Where was the deviation? In flight, and it wasn't on the ground. Now, there wasn't much more that we could describe this. It was a leakage, it was a rupture, not a leakage, it was in flight, and it was tank number 2 versus where it could have been. It could have been tank number 1, the rupture, but it did not happen there. It could have happened on ground, it did not happen, it happened only in flight. And it was not a small leakage, it could be small leakage, but it was a rupture, a blast of the oxygen number 2 tank, 2 number tank. And then they looked at the distinction with changes in the tank 2, and they had found that 2 weeks before the launch, a ground crew had piped liquid oxygen into both the tanks to count in a countdown demo. Now, after that test, they had difficulty getting the oxygen out of the number 2 tank, not number 1, right? So that's a distinction. And to get the oxygen out of the number 2 tank, they had activated the heater inside the tank to vaporize some of the liquid oxygen, thus providing pressure to force it out. They had kept the heater on for 8 hours, longer than ever before being used. Although the protective switch was provided to turn off the heater before it became too hot, the switch got fused in an on position. It got fused because of the heat, because the ground crew had connected to a 65-volt power supply instead of a 28-volt supply. So that is the distinction. So you see, something was happened with tank number 2 which did not happen with tank number 1. And that led us to find the most probable cause, that switch being fused in on position in tank number 2 because the ground crew had connected it to 65-volt power supply instead of. So switching on the electric heater switch remaining in on position because of getting fused was the most probable cause. And they found that they confirmed this when they investigated that the crew turned the heater on briefly to get accurate quantity reading while in the flight. So all was good till the time crew turned the heater on briefly to get accurate reading. The fuse switch created an arc that overheated the oxygen in the tank, raised the internal pressure tremendously, and blew the dome and much of the connecting piping into the space. And that caused the rupture of number 2 tank, not of number 1. The number 1 got affected because of the connected piping being affected as well. So thank you so much for watching this video. I hope you enjoyed listening to this case of the rupture of tank 2 or of Apollo 13 trouble and what caused that. I hope you enjoyed how you can use the problem analysis method to find the root cause of the problem and see what you could do from there.